Did you figure out things to at least a direction to go in?
When they get,
Alright. That's fine.
come back from school, then I go to bed here. So it's really the overlap.
So, you want to meet downstairs by the hotel?
Yeah, that way you can
Yeah, yeah.
Alright, let's get this session in 10 minutes. Yeah.
So what time is it? It's 3:20.
You start at,
I think it's 3:20.
okay.
Half an hour break, or is it?
Huh? What'd you say about 3?
Do we start at? No, it started. Here it says
We're
that-
supposed to start right now.
Yes, you are right. So.
Could people start taking their seats? We've reached our starting time. And anybody who's not here for MPLS, please find another place to chat. Yeah. You have to do something to turn this thing on.
Oh, there's a button here. It doesn't work. No, it's on.
Let's just.
With the green LED.
What does it push me?
I have no clue. This one is also on. Or maybe it's for. Yeah.
So, as George said, please take your seat. Would it be a good idea to close the door also? Someone in the back of the room can do that. Ah, silence.
They work pretty well.
Yeah. Good doors. Blue sheets. Okay. So we're ready to start. If you're going to present, please come up to the front of the room. This is the MPLS working group meeting for the first time on its own in Seoul. We had a joint meeting Monday with C-Camp, TEAS and PC, discussing mostly Jang modeling. Today we are going to focus on more MPLS specific things, I hope. You never know when Karate is presenting, it can be anything. So I think people are still dropping in, so allow them 1 or 2 more minutes. You can start putting up the slides. So you've been here almost a week now, so this is a note. Well, basically the message is that anything you do here, read, write, sing, dance, whatever, is considered a contribution to the IETF. And when it comes to IPRs and copyrights, you are actually responsible for what you disclose. We have a number of. I have a little bit of a problem. I can't see the main screen, so I have to look at this one.
Look at my screen.
Yeah. So we have a number of links here. The data tracker for the working group on the top. There are also links for note takers. We are extremely grateful for Rakesh to take notes. But if anyone wants to type into Etherpad, that's fine. Especially helping capture names of speakers at the mic. It could be hard from time to time. Then we have a Meet Echo. I don't see. Is anyone online?
Okay. One guy. Yeah.
One guy. Okay. And then you find the online agenda and the slides at the link at the bottom. Here is the agenda. It looks a little bit thin. We actually did quite a bit of the... Actually, what's happening just now, I think, in a number of working groups in this area of the IETF is that we're doing most of the progress around Yang models. So what we're doing here will allow people to actually dive deep into things if necessary. And you can ask the tricky questions. This has already happened. That is history. And the reason we keep this is for backup history. You can go back and see what we actually did on those type of slides and actually compare with the previous set of slides of what the difference are and what the progress are. We have started to circulate the blue sheets. Please fill in. And when they reach the back of the room, please see if everyone has signed, and if they have, pass them to the working group chairs. We haven't had one single errata since last meeting. I had one of my earlier working groups, but L2 VPN, but we fixed that pretty quickly. We have liaisons. We have sent 2 liaisons, and they were response to at UT study group 15 on OTA standardization work plan, and then we actually also liaised the Mpls TP shared ring protection to study group 15.
Excuse me, Loa.
And we got
You're going to need to get closer to the mic.
Ah, okay.
It's not picking up your voice.
You have the same problem as I have. You don't hear. So what I said was that we also liaised Mpls TP shared ring protection to study group 15. And we also would like to thank Eric for doing quite a bit of job on shepherding this document. Eric, just as you know, you're not done yet. There's a piece to be done. Okay. Here are incoming liaisons. So we looked at this. 1 are for information. We're not going to do anything about that. 2 are for action. We are going to create a response. I don't know if Scott is here. Scott has been hijacked by non-com, so he sits in the non-com room most of this meeting. And one of them are a liaison that is a response on one we sent, and that goes more or less to David Sinnercrope to look at what's happening to David Sinnercrope is the shepherd for the hitless PSM draft, and we will try to figure out what the actions will be, and then we need to tell our UT study group 15 what we have done. We have 2 new RFCs. That is 2 better than last time. One is the LDP extension to pseudo-I binding, and then we have a label switch pass and pseudo-wise trace over MPLS network using entropy labels. The last one was, at least for me, a little bit tricky to get my head around, but I think I finally could actually shepherd it. And we have four new working group drafts, and the blue one, the MLDP Yang, has actually been split into two, so we actually have 5 new working group drafts. And this document was on the agenda on Monday. On the other ones, I think I'm ready to talk to Eric Rosen about start progressing 3107 bits. It should be in pretty good shape. And then again, I'm not sure about the last one on this list. I think that's actually a Spring document. It's listed in the name. Name indicates that it's a Spring document, and I will check that. And of our like 20 working group documents, about half of them has been updated, because most of the documents on the previous page were also updated. The Mpls TP APS update is in working group last call. It's a little bit longer last call, because when we do last call over a IETF week, we don't count the IETF week, so it will be 3 weeks.
So Laura, I think I suggested that flow ident was ready for last call. I just wonder what's happening with it.
Okay. So yeah, I have a little piece of information for some of the documents. The flow ident, I'm actually waiting for the last author to respond to the IPR poll, and that will actually trigger the working group last call.
Can I help you kick any authors?
Yeah. Someone with the name that starts with an R. Or said, whatever.
Yes. Okay.
The top one is currently in a state where we are waiting for a decision for someone to start solutions work. The Mpls opportunities encrypt is currently, and let's see, is Adrian or Stephen in the room? Okay, so the information I have is that document is currently being implemented at some university for a test implementation, and after that we will go ahead and see if we want to make it an experimental RFC. And the second to last one, the Mpls MLDP MIB, I actually thought that the previous MIB should be the last one. I have talked to Benoit about this one, and it's a strictly read-only document, and Benoit had no problem actually to progress this one. So we will look at this history is that I thought I could actually say this should be superseded by the MLDP Yang model, but authors say that they have implementation and they have customer on it. Benoit says it's a strictly read-only document, so no problem, just go ahead and do it. The Mpls LDP MRT is probably on my, let's see, Stuart. No, you were not involved in that. We have a problem with that document that is stuck in Shepherd write-up, I think. Me. I'm the culprit. Okay, next play. So we have so what happens just now is that we have documents spreading out which have Mpls relevance. in other working groups. I have told a number of working group chairs actually to send information about working group last calls to the MPLS mailing list. We have one of them going on just now, and it generates quite a bit of traffic. And then we have, okay, there are IDs, there are working group documents, and there are IDs in other working groups. But if you have time, please follow this if you have an interest of the other working group, because there is always some type of impact on MPLS. So this is so the shared ring protection. Eric, do you want to tell us what's going on there? I think you know better than I do.
Yeah, I have no slides.
You have that one.
Yeah. So the status right now is that it's back on Hoop's plate. He's expecting to have an update ready to post any time now. We've discussed the details of the remaining changes. That should be the last one. At that point, I think I just need to do the Shepherd's write-up, and then I'm pretty sure that's
so.
it.
If I understand correctly, this is your review as part of the working group last call.
That's right. There were other comments as well, but all the comments that I'm aware of have been addressed once they do this last update. And at that point, I believe, am I mistaken in thinking the only thing I have to do is a Shepherd's write-up?
So in principle, everything is already agreed, and it just needs to update the document to reflect it.
Yeah, that's it.
Right.
And yeah, you will be involved in writing the Shepherd's write-up also.
Yeah. Okay.
The linear protection MIB, which I thought going to be the last MIB, is waiting for a Shepherd's write-up. Actually, again, waiting for me. The RSC 4379 BIS document is a little bit better than it says here. It's actually approved by the ISG. The IANA has started to take actions on the document. So if you go to IANA pages now and look for parameters that is defined in this document or in document that has been obsoleted, it actually says 4379 BIS just now in the IANA registry. Other than that, I think it's just coming along fine. I don't see any problems. Okay, next page. We have a number of documents. Deborah, would you please send the MPLS TP temporal hitless PSM properly back to the working group, get it into ID exist. It's in AD watching now, and AD watching is a little bit, we can't do really what we want to do. We have the MPLS app-aware TLDP submitted to the ISG for publication. The MPLS-based Yang model, we had the authors promising to try to have it ready for working group last call prior to Chicago. So we're starting to do last call on Yang model soon. And the MPLS residence time is also submitted to the ISG for publications. We have a number of new IDs. They are, so if you wonder what we're doing here, we have, our table is too small, so we can't actually. There is a, they are kind of all over the place, these documents, especially the first one. there's actually again a suggestion to change the label format, moving bits around and having to mean something else. We might do it, but we need to discuss it properly, and we need to have some presentation of it. And there has been no interest in actually taking it to the working group. There is a draft Changpeng Mpls LDP that they have promised us that they will be ready to present it in Chicago. And then Kireti, you have a message back home. You need to rename the drafts so they properly. If you hadn't discussed them on the agenda, we wouldn't have found them. So please tell the authors that actually to name them correctly. There should be draft eSale MPLS LDP and DashMook MPLS RSVP. Okay. I don't have much to say about that one. No, that's fine. So progress update. So the base and static Yang model, I talked about a little bit earlier. At least base, we will see progressing before Chicago if the authors actually keep their promise. There are a number of small things that they need to do, but nothing much. We have warnings and errors on the Yang compiler. Other than that, I think it's fine. And on static, we need to add the point-to-multipoint support. We have one other draft that has been there for some time. And this one is actually there is an outstanding review on this one, and we did a Shepherd review, comment from Nick, and it has been kind of in limbo for whatever, 25 days, 1 month. Yeah. But they have actually promised to come back with a response pretty soon. I haven't seen it yet, but I hope they come soon. Okay. Yep, that's it. Any questions? Not really. So now I can go to sleep.
So Stuart, you're up.
Turn this around, do I, and stand in the box? Okay, so this is a draft we've been working on for a little while, as you remember, and what we've done to it is to put in some text that deals with delay and jitter. We had packet loss well covered, but this is now delay and jitter. So next slide, please. One of the things that I would like to discuss when we get there is what types of measurement we should take under delay and jitter. We've put several in, but I think we need to hone it down to just 1 or 2 formats, and it may be appropriate to combine some. And I'm having some discussions with IPPM to try and align with what they think it should be. Next slide, please. First off, there's single packet delay measurement. So this is when you set up an OAM message that's just going to measure the length of time that this message took to propagate through the network. This works exactly as you would expect it to, exactly as it worked for MPLS TP, except it runs on a synonymous label so that it's got exactly the same characteristics as a packet that it's trying to, an ordinary data packet it's trying to characterize. So it's an OAM message disguised as a real message, and it works exactly as base 6374. Next slide, please.
Good.
Yep.
I have a question. I talked about synonymous labels with people, and there are some confusion. Can you take 2 minutes to explain what is really? I know you can say go read the draft, but I would actually like
No,
to
no, no,
hear
I'm
it.
not that rude. So, a synonymous label is a label that is slightly more sophisticated than the labels that we've been using so far. It's a label that's actually got twin characteristics. So on the one hand, it's perhaps a VPN identifier, a pseudo-wire identifier, an LSP that's going to get us across the network. But it has a side effect that we've specially sort of negotiated with between the two peers, and it's also of particular use if we want to know the source of the packet, because in MPLS there's no source identification, and so what we do is if I'm a sender and over there is a receiver, I have a word with the receiver and I say, you know, I'd like you to, for example, count how many of these packets I've sent to you. So why don't we have a private special label that we will use? And so instead of sending it on the ordinary VPN label, for example, I send it on our special sort of alternative label, synonymous label. And what happens is the far end treats it exactly as if it was the original label, but it also does something special. And one of the easiest special things to do is to trigger a counter. For example, the counter of the number of packets received from the source. And because it's a special label negotiated between the pair, you can discriminate it from all the other packets that are arriving on that VPN. It's in the draft, and Kariti's going to ask a question, but Kariti's been through 3 copies of this presentation.
I mean, does it not, as you said, it's Kariti. Does it not bother you that these packets may be load balanced differently from the rest?
Yeah, so there's some text in the draft, and it says, if this is a problem for you, it may or may not be, then use your entropy label system, because if you use the entropy label system, it neutralizes the 5-tuple effect.
So,
and the bottom and the balance.
yeah, speaking as co-author, one of the main motivations here is there's a whole lot of hardware out there that already counts packets by labels. So the whole idea here was to have a mechanism where you don't have to build new hardware in order to get these measurements.
So yes, a little bit of control protocol, and pretty well all the existing hardware will allow us to do very accurate delay measurement, for example. And we thought this was a really cool thing to do, and would probably get into the field a lot quicker than if we tried to do anything cleverer. So hopefully people sort of have got a flavour for what synonymous labels are. If you read the draft, I talk about it in some depth, and if it's not understandable from the draft, please send feedback, and the authors will make sure that it's clearer. So we want to do a delay measurement, right. So the first thing I'm showing up here is a reminder of how we do packet loss measurement. So what we do is we color the packets into batches. And the reason we do this is because it gives us a way of synchronizing the 2 ends that's resilient against ECMP, for example, packets arriving on different interfaces, and means that we don't have to have quite such precise timers. This is a technique that is being pioneered over in IPPM, and what we're just doing is showing how to do it in an MPLS context, and it works really easily. But that's not quite good enough if we want to do delay, because normally you'd want to do delay of a batch of packets over a much shorter interval than you would want to measure packet loss, because packet losses are so small that you usually measure them in large quantity of time, but packet delay, you perhaps want to know what it is now. So what we do is we introduce another synonymous label, So the packets were being continuously measured on the A synonymous label, then the B, then back to the A, then the B. We want to do a batch of delays. We introduce a third synonymous label, which has the characteristic that it's treated like an A label, but it's going into the delay measurement system. So it's still going to be forwarded as it was, but some counters are going, some timers are going to be accumulated or something. And of course, if we might want to do it over, even shorter intervals, and so we might need two labels to substitute for doing this. We do need to make sure that we have guard bands in there. I think IPPM have been looking at this in quite detail, because you want to make sure that there's no ambiguity in terms of which period a packet is. You need time for the packet to actually get to its destination. Let me go to the next slide, please. So one of the concerns I've got, and I really need feedback on this, is what combinations of loss delay do we need to do? And I'm thinking that actually the sensible thing to do is to always measure loss and tweak the loss to occasionally measured delay if that's what you want, because that's one less level of complexity, and it turns out that loss is the easiest of the measurements to do anyway. So actually, I think you're probably going to get you to read the text, because what we tried to do is to put down some rules for some constraints that made it simpler, so we didn't have to do huge numbers of combinations in the hardware. Next slide, please. So how do we measure delay? Because I mean, you can just measure delay of a batch of packets. So one of the techniques that you need to do is to, for example, measure the 95th percentile. And that's really hard, because that actually requires sort of proper math and stuff. So one way of doing this is to set up some buckets or some bins and look at the delay between this packet and the previous one in the series, and depending on what the delay was, just tweak a counter into to record it. And by setting up the bins, say 1 microsecond, 2 microseconds, 4, whatever you decide they should be, and they really have to be configurable, you can sort of capture a sort of a piece of the profile. So if you, for example, if you expect that 95% of the packets will come at, say, 4 microseconds, then you'd be interested in what came in at 5 and what came in at 6, because they're the really late ones. But I guess you'd also might like to know whether actually they're coming in a bit faster than that. So you might have some other bins that say 1 and 2. I think that has to be configurable. So, and there's the sort of structure of the packet we might use. So next one, please. Being a naive mathematician, which apparently isn't good enough for this job, and no, seriously, we have to actually, it turns out that because the statistics are multimodal, we can't just simply do what I'd sketched out here, which is to record mean and variance. And I say variance rather than standard deviation because there's no square root needed. So what I was proposing to record is the sum of the delays for the batch. Well, you divide that by the number of packets and you know what the mean delay is. Min and max will tell you if there's any strange effects going on. And if we record the sum of delays squared, which you can possibly do in a piece of hardware, then you can get a more sophisticated computer to go and figure out what the variance was. So if you've only got a monomodal distribution, that's actually not a bad way of doing it, but I'm worried as to whether the statistics are good enough. Next slide, please. So the next thing, and this again comes from work out of IPPM, is to record, this is for one-way delay measurement, to record the time of the first packet, the sum of the timestamps of the packet. So you have an accurate clock and you record the timestamp of the arrival. And you add all these together, and it turns out that if you do this, you can track the same packets at multiple points in the network and work out how the delay got accumulated as you went through the path, which I thought was kind of a cool thing to be able to do. Next slide, please. Finally, this is as less reliability on the hardware to collect things. This is kind of just a sampling sort of technique where you use a different synonymous label in the middle of the packet stream, and just pick out a few of the packets to measure it. Massively reduces your data rate, allows you to move more stuff into the OAM path, the exception path. And we also think this may be less impacted by ECMP effects. Next slide, please. So I need some comments on this, particularly in terms of measurement preference. And I suggest that do get this right and then go back to the architecture and control plane work. What I do think, though, is I think it's appropriate to make this a working group draft, because it's not while it's not perfect, the fact is that we know we need to do this, and I would like the working group to accept some responsibility for the text, so it becomes a joint project rather than the opinion of the authors. Question.
Tal Mizrahi, Marvell. I've read the draft. I think it's valuable to the working group. I just want to ask something. It looked like when you perform both loss and delay measurement, you use 3 synonymous labels?
Yes. Yes, because because what you're going to have to do, you have one that's the loss measurement, and if you're going to do sub measurements in there, you use a pair for the delay. So actually, it's probably 4, isn't it, that you need?
Stuart.
Yeah.
Okay.
So the delay measurement is an OEM packet, so you don't want that counted with the other packets. And then 2 other labels allow you to alternate between 2 batches of counting, so that you can clearly get the clear edges and the results.
Okay.
Note, though, that you only need this for an instrumented flow. So the ordinary flows, the ones that you're not really bothered with, they can just carry on their existing ordinary labels. This is one that you brought into focus because you're trying to diagnose. So we're not quadrupling the number of labels needed. What we're doing is we're adding a number of labels to a flow that's currently in focus for measurement.
Okay, so I just wanted to point out that earlier this week, a bunch of us presented at IPPM a new work which is called multiplexed marking, and I think the same concept can be applied here and basically allow you to use only 2 synonymous labels if you're willing to make an assumption about a certain guard band between when you start to perform the loss measurement window and when you start to perform the delay measurement window.
So I think yes, that's right.
Well, no, I mean, the synonymous label, I mean, the S is actually a misnomer for being a synonymous label, because the A and the B are going to get treated by the exact same thing. So if it's going off to a particular VPN, it's going to get mapped out an interface. So we don't want to mix any OEM or strange stuff in there.
So this what I saw that presentation, and it was about a reduction in the number of labels or number of markers you need, and it's actually more important in the IP context than it is here, where you've got only the quas bits to use. The protocol work we're describing here is completely invariant with regard to that. It's just a way of reducing the number of labels you need, but there's nothing in there that really talks about the number of labels that you need. Nothing anywhere in the draft. How you build your application is up to you, and I think either method will work. You just need to, but the cost, I think, no, either method will really work with the text that's described, as far as I can see.
Okay, so you're not disagreeing with me.
I am a little worried about the spinning around that you have in terms of the reuse of the label and the ability to get yourself confused.
Okay.
And I'm not convinced it's needed in this I'm not convinced we need to minimize the number in the same way that you do in IP, where you're actually stealing bits out of the type of service, which is
Stuart?
Yep.
I have, I think, 3 questions.
Yes.
First, could you send a mail to the MPLS mailing list
Sure.
pointing out where we have the information and what the questions really are?
Sure. Yeah.
Can the authors get in contact with him and discuss and see if there is something in his proposal that we want to take?
Yeah, I'll probably put some text that say you could do it one way or the other.
Okay. And then, Stuart, how many slides do you have left after this one?
I think this says next steps. That's usually the last one.
Okay, so, okay, that's fine. Go ahead.
All right. So
Yeah,
I'd
thanks.
actually like to put some working off for though, Noah, which is that I think we need to find out whether the working group should adopt this, so that, as I say, it's a community effort and not just the author's opinion.
So the question I forgot, should we actually socialize this draft with the IP PPM working group?
So if you want to do that formally, that'd be great, but it's already being done informally.
Okay.
Yes, I mean, for example, Al, who's been doing a lot of work on that, and I've had had discussions, and it gets mentioned over there from
Fine.
time to time.
So now you can repeat the question to me.
So the question to you is, can we start the process of making this a working group document so that it becomes a working group document and not just an author's opinion document?
I don't see a reason not to do it, but I haven't read it recently, so I need to read it first, and then we can start seeing.
So there are a number of ways of doing delay measurements, but some of them impact what the far end edge node has to do. And what we want is wide agreement on what we expect those things to do and what we don't.
And the discussion I've had with Giuseppe, who does a lot of work over in IPPM, is that we will work with the measurement experts over there we'll work with the measurement experts over there to measure what they say, what they want us to measure. So I think we're going to take, we should take input from them, who spend a lot of time thinking about that,
Right.
to design our actual measurement payload. And I'm thinking in terms of combining some of those messages up there, just so that we have one single sort of measurement, but you return 0 if you're not actually capable of doing it. So just to minimize the number of options that you have. Okay, so
So can I ask a couple of questions? Who has actually read this draft? A fair number. How many things is actually ready to start the process for working group adoption? About the same. Okay. I'm a little bit uncertain myself.
Yeah.
Okay, thank you.
all right, thank you. So I think that's, unless there's no more any more questions, we'll go to the next presentation, which I think I stay up here for. Right. So this is a piece of work that I recently joined, that we've been that's been milling around here for a little while, and it's based on an observation that you can use a label stack to do service function chaining, meaning that you can use an existing forwarding plane to do most of the work. And this is a description about how to do it. In fact, I think, having reflected on this, that this is so relatively simple that we could just make it an applicability statement, because I don't think it needs any new protocol work. And that'll be really cool, I think. So next slide, please. So what does a service function chain do? Well, it steers a packet through an ordered set of functions. And an ingress classifier picks up the packet, figures out what the path is and what the functions are going to be, and it basically puts an instruction set on the front of the packet to do it. And actually, labels are a pretty good instruction. So what we can do is to put an instruction set on the front of the packet in terms of a number of labels, and we'll show you how that works. And by the way, this is pretty well exactly the same thing that segment routing is doing. So actually, this route here is we're going to kind of get to a unification between the core aspects of segment routing and the core aspects of service function chaining, with a goal of running it on existing hardware. And that sounds like it's worth thinking about. So in this draft, we show how to do it. It is technically called up in the service function chaining draft, or RFC 7665, as transport derived what is it, something function forwarding, yeah, anyway, SFF, service function forwarding. Thank you. Forwarder. Thank you. Next slide, please. What we're going to do is, the forwarders are basically MPLS segment routing nodes. And what we're going to do is we're going to get them to advertise nodal SIDs for themselves. So that's exactly what segment routing does. So if you put a series of these on the front of a packet, it will go from hop by hop in the ordered set to those forwarders. And then the forwarder has got is attached locally to some functions. And actually, you don't need a global label or nodal labels to identify those. Ordinary, boring, regular MPLS labels are all you need to advertise them, because they're attached. Once you get to one, the context is immediately obvious. So by putting a series of ordinary labels to identify functions with nodal labels to identify forwarders, we can get the packet to go to the functions we want. So the classifier imposes the label stack. LSRs forward to the service function forwarder using the nodal labels or adjacency labels if that's what you want to do. When they get there, the right thing happens. Let's look at the next slide. So here's an example. I want the packet to go through forwarder 1 to do service function 1 to forwarder 2 to service function 3 and then out. And so what I do at the front in the classifier is to put the nodal label of the forwarder followed by the service function that needs to happen. Of course, if I want to go to several service functions when I get to that forwarder, I just put several labels on there. So just ordinary MPLS, and it should sort of like falling off a log. Next slide, please. So IP connectivity. If you need to bridge across a non-MPLS forwarding zone, you simply put an IP label on the front. And by the way, it can be a V4 or a V6 label. And there are several ways of carrying MPLS over IP. You could carry it directly, RFC 4023. You can carry it in UDP, or you can carry it in L2TP v3. The interesting one is the UDP one, of course, because that's got a load balancing system that just works in the existing hardware. It's got an IP packet on the front, it's got a UDP pair of ports there, and it kind of knows that when it arrives, it strips all that off, looks at the instructions, which are labels, and off it goes. And when it needs to go across another one, you put this back on. And by the way, you could do segment routing over IP using this thing with pretty well existing RFCs. Next slide, please. So this is showing what's happening in that context. In the case of SF1 to SF2, there is no MPLS connectivity, so we just put an IP header on the front in whichever encapsulation you decide, and that could be IPv4 or IPv6, which also seems a cool thing to be able to do. Next slide, please. So we think this is an interesting approach that allows a majority of the SFC application and functions to be delivered using technology that this working group has had sort of perfected for a long time. we need to look at how we signal this to see if there's anything extra we need to do in the signaling. Remember that in segment routing, it's the IGP that's doing the signaling. You don't really need LDP. And there's the question of which working group do we need to take this to move it forward? And that's really a question for the chairs.
Okay, I think we need to discuss this with service function chaining first, and then maybe with ADs and.
Right.
Yeah. Okay.
So I'm thinking that maybe when we need to look carefully, this may just be an applicability statement, because it's showing how to put together existing technology to solve a problem. Sorry? Right. And applicability statements are usually welcome because they're a simple way of solving a problem. Question?
Stefan from Orange. First of all, sorry, I didn't read the document, but I will do because it sounds interesting. I have just one concern, is that today, just by doing segment routing traffic engineering, we have some troubles with the label stack and with the existing hardware. So I'm wondering how it's possible to add more labels now, at least now. Maybe in future it will be
right.
okay.
So there are actually there are a couple of other techniques you can use if you're short of labels in a system, which is one of the labels could be the label stack that another router needs to function. So
Which
one
is
of the
true,
one of
which
the
is true,
functions, yes.
But you will add states within the network, and one of the goals of segment routing was to prevent to add at least too much states.
Yeah, indeed.
It's a question of trade-off.
Yes, but it's a trade-off, exactly as you say.
So my remark is just to tell that we need to take care.
Yes.
Question from someone that's not that familiar with hardware. Isn't the problem with hardware the number of labels you need to
Yes.
to treat? And this is actually
No, it's not the number of labels. It's the number of labels you need to push. That's the problem.
okay.
You
so
never need to process any more labels than you do at the moment.
This is only a problem on the ingress.
Yes.
Okay.
And the problem is that a lot of the cheap hardware was optimized around, VPNs and pseudo wires, and you only need 2 labels, so it can only push, like 2 or 4. And this has been a thing that's dogged segment routing all along. But given that people know about segment routing, the hardware is going to become more capable. And as I say, the first thing you might want to do is to deliver this to a service function, which is software, and just puts the label stack on for you.
So with regards to label, there being the author of MSD draft, which does exactly that. It signals the capability of hardware or hardware and software
Yes.
to push particular number of labels. So you should definitely look into it. There is corresponding draft in PC, as someone will have to provision it, which talks about service chaining and segment routing provision over PC.
Okay.
And at the end, you'll be signaling MSD to path computation entity, which will compute the path. So I think you should definitely look into the concept of binding seat, where, as you said, you could use binding seat to provide segmented segment routing tunnel. So where next or next node could push additional number of labels.
Indeed. That was invented like the week after we originally invented segment routing. So it's a well-known concept. And I think it actually is the answer to this lower performance hardware. I'm hoping to be useful, this really needs to just piggyback on pretty well everything that segment routing has done.
Yeah.
So it's really just a different way of doing the data plane, some added functionality in the case of service function, and some simplicity in the case of IP.
And perhaps also discovery of service functions on the node would be in place, so BGPLS extensions.
Yeah, but I'm kind of assuming a lot
Yeah.
of that's already exists. We can piggyback on what exists.
And I think Spring would be the right place
Yes.
to proceed.
Okay.
Just comment to a previous comment, not Jeff, but
Yes.
on the number of label as a
Yes.
concern.
Yeah.
I don't think we should be talking about number of labels as a concern. I remember Kiriti telling me for entropy labels that number of labels is not a problem.
I think the work. So actually,
If I'm answer, so if you look at let's say Broadcom, So SGX does today 4 labels, DNX does 7 with no changes. So you hit limitations pretty soon, unless you recirculate or do some other magic.
Yes.
You're stuck with reasonably shallow label stacks.
So Stuart, 1 second. I'm cutting the line after Adrian.
All right, Kyle Rose, Sandmine. I have a concern about the implication of a large number of labels, or just labels in general, on the service functions themselves. So if you have 8, 10 labels on your packet, and the service function has to actually act on the inner portion of the packet, it's going to have to parse through every one of those labels. That's going to be fairly intensive CPU-wise. That's number one. Number two.
So it has to go down each one and look for the
bottommost stack.
But we're used to looking for the bottom of stack, right? I mean, it's only you look at one bit,
but
go 4 bytes later and look at the same bit again.
Are these like? But I mean, these service functions, were they expecting to have to parse through a large number of labels when you provision them, when you laid out the network? I mean, it might hurt performance. Is my only.
I suspect that this is the least of your problems in a service function, to be quite honest, because we do this sort of thing in real time on the main stack at hundreds of gigabits to get it around the network. So
all right, but one other concern, more functional, is the ability of the service function to inject traffic backwards. So something we've been discussing on the SFC mailing list is how, when a service function needs to reply to something or something along those lines, it needs to understand the reverse path through the chain in order to get the sort of correct functionality backwards. Just something to keep in mind. I don't know if there's an obvious solution.
So this will at least do what you do at the moment with VLANs and pieces of Ethernet cable.
Yes.
All right, which I suspect will chew up a very large fraction of the problem.
All right.
Yep.
Okay, wait a minute. Note taker wants to have your name.
Kyle LaRose, Sandvine.
Okay.
Lucy Yang from Huawei. I think this mechanism very simple. However, this service function, they do have the scenario there's load balancing among the multiple service function instance. So for this case, you're assuming this in the classifier, we're going to select one of them, not like locally doing the load balancing.
Well, so you can have any cast segment routing labels, and you could presumably have any cast function identifiers. You just have to use them from the global table rather than from the local table, which we were showing here. Using the local table has got advantages, but if you want to anycast it, you can anycast anything. Nodes and functions are exactly the same as far as the notation here is concerned.
Right, but the label to represent the service function, right?
Yes, that can come out. That can come out of the nodal table space as well.
Right.
Yeah, I mean, they're just allocated labels, system-wide allocated labels. You can take those, you can't have quite as many nodes in your system, but you can certainly use nodal labels to identify functions. Labels are labels. Labels are instructions. And what's the type of instruction you want to associate with them, entirely up to the engineer who's laying out the system. We can talk offline if you need clarification.
So about 2 years ago, I built prototype doing exactly this. What we figure out hardware, there's pretty much no virtual network function understanding MPLS encapsulation.
Right.
So we end up doing stripping whole MPLS header and passing pointer to the egress, which is cumbersome operation. It's very expensive in terms of processing. And if your label stack is 15 labels indeed, and you need to strip them on ingress, pass them to egress, and rebuild the packet at egress, it's a problematic thing, and we need to figure out how to deal with it. Either have more virtual functions to support MPLS and CAP.
Right. Adrian
Farrell. Yeah, thank you for this draft. I think there are some germs of good ideas, and there's a lot of similarity with some stuff I've been working on but haven't posted yet. So I'd like to get with you and align.
I believe we already have this in our diaries.
Yeah, and
Good.
I'd like to do it. I'm not doing it because I don't want to do it. What I wanted to do was just point at a draft that we had on the BESS agenda this time round for advertising SFFs and service functions in BGP, so that before anybody goes off and reinvents any BGP extensions, they should maybe look at that and talk to us.
Right, and I'm delighted to work with you on trying to putting together a solution. I think we could drive this quite quickly.
Delighted. I want that in writing. Stuart is delighted to work with me.
Okay, that's me finished.
Okay, thank you, Stuart.
And I'll take some guidance on where we move this work next.
Okay.
Hello, everyone. I'm Xiaohu from Huawei. This job talking about how to connect Mpls Spring Island or nodes across IP networks. This job is complementary to the previous job.
It's not working. I know.
Oh,
I know.
oh,
I know.
okay. Next, please. The segment routing problem statement said clearly that Spring architecture must allow incremental deployment. To support incremental deployment for Mpls segment routing, currently, Mpls should be enabled on those non-Mpls segment routing node. This is fine for Greenfield, where the non-segment routing node has enabled LDP. However, it seems a bit complex for Greenfield, where there's no need to enable another Mpls signaling. Because this is the beauty of the Mpls segment routing, is that clearly Mpls segment routing is tending to simplify network provisioning by only using a single protocol, that's the IGP. The incremental deployment for IPv6 segment routing is much better than Mpls segment routing, since there are no requirement for non-SR routers to be upgraded. They just need to support normal IPv6 forwarding. However, this incremental deployment has issue of encapsulation overhead, because it's need to end a list of IPv6 addresses as explicit path information. In addition, this incremental deployment capability is not available for IPv4 underlay networks. Next slide, please. To facilitate the incremental deployment of Mpls segment routing, this document proposes a very simple approach of replacing the outermost LSP with an IP-based tunnel. In this way, there's no need to run one additional Mpls signaling protocol. More importantly, it can be looked at a universal source routing method, which integrate the best of the two worlds that are IPv6 segment routing and Mpls segment routing. The Mpls label stack contained in an IP packet, which is either IPv4 or IPv6 packet, is used to indicate the source path. If the packet happens to be IPv6 packet, it can be looked at compact IPv6 segment routing variant, where the explicit path is encoded as a list of short IDs instead of IPv6 addresses. To reduce the current hardwares, those short IDs happens to be Mpls labels. Next slide. There are at least two use cases for this approach. One is Mpls source routing based server chain, which have been talked by Stuart. Another use case is traffic engineering in the dual plane network scenario. In this scenario, only a few failed, such as entry and exit node of each plan need to be MPLS and routing capable. All other intermediate nodes just need to support normal IP forwarding capability. Next slide. This figure shows how to connect MPLS pin nodes over IP networks. When receiving an MPLS packet with top label indicating a next node segment, that is node Z. If IGP next hop toward that node segment is a non-subrouting router, X would forward the MPLS packet towards the next node segment by using an IP-based tunnel, such as MPLS over UDP. If the top label is not a PHP label, X should swap the top label to the current label, which is significant to the next node segment, and then encapsulates MPLS packet within an IP tunnel. If the top label is a PHP label, and this is node at the bottom of the label stack, X should pop that label and then performing the form the bow encapsulation. Next slide, please. There have been some discussion in the mailing list whether we need a draft describing such usage. According to RFC 3031, when an MPLS subrouting enable router that X receive MPLS packet with top label indicating a given node segment, its next hop toward the next node segment is a non-MPLS router. X couldn't map the packet top label into a next hop label forwarding entry. As a result, the packet would have to be discarded by X. Next, please. Here I highlight some statements in RFC 3031. We said clearly that in the bow use case, the packet would be discussed by router X. Next, please. We would like to hear more comment and suggestion on this draft.
So personal opinion, not as working group chair. I personally believe that the UDP draft is sufficient. That, you know, maybe it didn't explicitly say that it's adding something to 3031, but clearly, if you're sending, you have a mechanism to send MPLS over IP, then you can do the mapping, and you're essentially using an IP tunnel to get the stuff across. It's just not got. Oh, George Swallow. Yes.
Okay. Thank you.
So there's clearly a lot of overlap between this and the previous piece of work. My strong opinion is that particularly with the sort of simplification of the forwarding, the fact that it does V4 and V6, this is an area that we really need to get our hands on, and we should be able to get to customers relatively quickly.
Okay, so now it's Kireti show for, you actually have like an hour for 4 rounds.
No, I don't have an hour. I don't think you guys have an hour. Okay, so going back to the RMR draft, the resilient MPLS rings, the idea there was that first, there's the problem statement of how do you do good MPLS resilience in a ring, in a specific topology. And once you do that, the focus so far has been how how do you do the discovery of the ring? How do you decide what is clockwise and anti-clockwise? And once you get past that, you actually want to signal two LSPs or two counter-rotating LSPs. So we want to show you how to do that in LDP, and the next slide is for how to do that in RSVP. Sorry, the next slide deck, but the next slide is fine. So basically you have LDP as a signaling protocol for MPLS LSPs. Typically you want to use, LDP follows the shortest path. So when you say, I get all these different labels and you want to pick the next router, you look at the IGP for what the shortest path is. But in the case of rings, you want to create these counter-rotating rings, counter-rotating LSPs. And so we have to find a way to do that. If you want to run LDP on a ring, it's actually the worst topology in terms of if something fails, how do I get the packet to where it needs to go with the IGP keeps getting in the way. And so we have multiple solutions for that, and they're generally, good solutions for general topologies. But in a specific case of a ring, you can use the topology to help you. So this is not necessarily a general solution. So you can use TI-LFA, or you can use different procedures. And the last slide deck that I'm going to speak to is how to use RSVP, but people have also shown how to use segment routing. But in the specific case of a ring, if you can establish these counter-rotating LSPs, you can use that for protection. So I'm not going to go more into that. We've talked about that. So I'm just going to go on to how do you signal this. So next slide, please.
Yeah. I have a question again on LDP. LDP is inherently multi-point to point.
Yes.
So will you have to disable that function in LDP on the ring?
No.
Okay.
No, I want to create a multi-point LSP.
Anything ingressing to the ring needs to be treated the same. It needs to be recovered just as well. So you want that traffic to go backwards around.
So if you wait a couple of slides, in fact, the difficulty is not so much LDP, which is inherently multi-point, as you said. The difficulty is RSVP, which is inherently point-to-point, and I want to make it multi-point. But we'll get there in the next step.
Yeah. Let's see if I... Okay. So everything that ingress on a number of points, but have the destination to the same point, you're actually doing the multi-point to point on that. Okay.
Yes. Yeah. Okay. So the first thing we're going to talk about is we're going to, in order to exchange all these things, we want to first exchange the capability before you can exchange a fact that says, I'm doing an RMR LDP LSP. You want to make sure that your neighbors can do this. And so there's a capability that's been introduced to say that I can signal this. And if your IGP says your clockwise neighbor is X and or your anti-clockwise neighbor is Y in this ring, you need to know that your clockwise and anti-clockwise neighbors can do RMR signaling. Now, if the IGP says, they're your neighbors, hopefully, they can do it, but maybe they know how to do RSVP signaling and not LDP. So there's a capability that says your neighbors can speak the language that you want to speak. There's another aspect here that you can create a regular LDP LSP, the normal transfer LDP LSP, and you can create these RMR LSPs. And you may want to say that in the case of a ring, you only want to create RMR LSPs because of the property that you can protect them nicely. You may want to do both. So it's an implementation, but the suggestion is that implementations consider on a ring when you start exchanging the IGP TLVs that say that we're on a ring and here's what's going on. You may want to say that in that case, I only want to set up RMR LDP LSPs, but that's an implementation detail. Next. So once you've exchanged this capability, you know that your neighbors are capable of or can speak RMR LDP. You want to say, hey, let's set up these LSPs. So to Loa's point, you're going to have a new FAQ element, and the FAQ element is going to say, I'm doing an RMR FAQ. And the address family says either IPv4 or IPv6. The length is either 32 or 128. I mean, anything else would be weird and funky. And the prefix is the egress. So this is where the LSP is going. And then you have the ring ID, because you can have multiple rings going through, they could be overlapping, or they could have common nodes. So you need to say, if you're interested in sending a packet to this ring prefix, which is really a host address, on ring 17, for example, yeah, here's the label for it. Also, we're creating these counter-rotating LSPs, so the ring flags say whether you're creating an anti-clockwise LSP or a clockwise LSP. So that's the format of this FAQ TLV. So you're saying, A, this is an RMR LDP LSP. B, this is the exit point, this is the egress. C, this is the ring ID. And then D, this is the direction we're going. Next. So here you see an example of two rings. If you look at node 10 and 10, there are two rings going through that. So you have to say, I'm trying to create an LSP that exits at node N10. I'm working on ring 18, or I'm working on ring 17, so you have to specify which ring. And then you have to say which direction you're going. So in the RMR, if you want to call it the architecture document, it says how to do the discovery. And the discovery is done using an IGP. And once the discovery is done, essentially, you want to create this table that says, for ring 17, N10 has a clockwise neighbor of N1 and an anti-clockwise neighbor of N9. And for ring 18, the clockwise neighbor is N1 again, but the anti-clockwise neighbor happens to be N4, N14. Note also that each ring will have its own notion of clockwise and anti-clockwise. So in this example, it says clockwise neighbor for N10 is N1 on both rings. That's not necessary. Ring 18 can decide that clockwise is going the other way. So the same link in two different rings may have different directions. Per is looking very, very intently at this. One other thing that's important is RMR is only partially about creating this easy, intuitive protection. There's another aspect, which is we're trying to automate this, automate the whole setup much more than you normally do. And I think this is trying to illustrate that. Essentially, ideally with very little configuration, the ring is set up, the auto discovery happens, the IGP says, here are the neighbors, clockwise, here's anti-clockwise, here are all the nodes in ring 17, here are all the nodes in ring 18. And once that is done, the LSP just gets set up. So you don't need special configuration for that. That's not so obvious or not so evident in LDP, which generally doesn't require as much configuration. But in RSVP, you typically have a lot more configuration. You have a lot of path computation that can get pretty fancy. So in the next draft, you'll see that. But in both these drafts, essentially, once the IGP is done and says, I have figured out everything in the ring, these are the nodes, this is a clockwise neighbor, this is the anti-clockwise neighbor, LSP signaling just gets kicked off. Okay, next. So the basic procedure, you have the egress LSR that says, I'm going to initiate the LSP. I'm in ring 17. Here's my prefix, or here's my host address. I'm going to announce a FAQ for this, an RMR FAQ. And it has to do it in both directions. So it's going to send a clockwise fact to the anti-clockwise neighbor and an anti-clockwise fact to the clockwise neighbor. And that's how the initiation is done. Every node does this. So as soon as a node is told by the IGP that here's your clockwise and here's your anti-clockwise neighbor, it will initiate these counter-rotating LSPs. A transit LSR, when it gets a FEC element that says, hey, here's this egress, it's trying to create a clockwise LSP, and it's working on ring 18, let's say, it should look at the table that you saw on the previous slide and say, I'm going to propagate this to the next, to the upstream LSR using what was on the previous slide. And essentially, it's going to get a label from the previous hop, and it's going to propagate it's going to allocate a new label and propagate it to the next hop, and then create the cross connect. So as this fact goes around the ring, say in the clockwise direction, you're creating the anti-clockwise LSP to that egress. And of course, every node other than the egress, and in a sense, even the egress, is a transit LSR, is an ingress LSR. So to Loa's point, you're creating a multi-point LSP. So you can also install what in Junos is an INET 3, Stefan is laughing away. Basically a route that says, to get to this egress, here's the label you use. So you're going to install a cross connect, and you're also going to install a label to get to the ingress, egress. I mentioned that the transit nodes are also ingress, but you can have, if you feel like, the egress node being an ingress. And so the funky thing about RMR is you're creating a loop on purpose. And the only reason that this might be interesting is that you can ping yourself through the LSP. So once the signaling comes all the way back to the egress, you now have a label that you can ping yourself, and you can make sure that the LSP is working. So you can send, at the frequency that you desire, a packet in the clockwise direction and a packet in the anti-clockwise direction to know that the end-to-end LSP is working. And of course, you can also have something like BFD on each link, but every link may work, but the end-to-end LSP may not work. So here's a very simple way of pinging yourself and making sure that both directions are working. Next. So, I've gone over this in the other slide, in presentations before. Essentially, production is SONET BLSR. You have these counter-rotating rings, and as you get the cross connects created that are, the anti-clockwise cross connect, and you also have the clockwise cross connect, if you cross connect them, whatever that means, you're going to have the protection. So if you get a label from your clockwise neighbor, and you've propagated a label to your next, to your anti-clockwise neighbor, you're creating the anti-clockwise LSP. And if you get the other pair of labels, you're creating the clockwise LSP. And if you connect them in the other direction, you're creating the protection path. So you don't need a bypass LSP, you don't need protection of other kinds. Next. So if you go with the idea that on the ring, I'm only going to use an RMR LDP FEX, so that I have these self-protecting counter-rotating rings, you still need to get out of that ring. Typically, you want to get out of the ring. So if you think of nodes hanging off the ring at the bottom, which might be cell-side gateways or DSLAMs or whatever, and nodes hanging off the top, which might be your service nodes, PNGs, whatever, you want to be able to connect them. You can establish automatic TLDP sessions to exchange those labels. So then you're working with, essentially you're working with hierarchy. So if N6 wants to talk to N11, N11's normal LDP FEC will be sent over the TLDP session to from N10 to N6. And then N6 will basically put a 2-label stack to say one is go around the ring in some direction to N10, pop that label, and then look at the next label and say go to N11. So you can automatically establish these TLDP sessions. So yeah, so this is how you get connectivity beyond the ring, and that's typically important. Next. So this is the first version of the draft. We want to put this out for you guys to look at, think about, and if you have any comments in terms of how it works or improvements on what it's capable of, please send them to the list. So if no questions, I'll go on to the next slide, which, oh, okay, fine, that works. This is kind of the architecture document. It's co-authored with me and Luis. Next. So we've been having a lot of discussions internally within Juniper as well as with my co-author, and a lot of discussions on how to implement this, a lot of discussions on how to do the signaling with LDP and RSVP. One of the things that we had in the original document and even in the last version was the notion of as you're doing the auto discovery, you say these are the 10 nodes that are in the ring, these are all the nodes in ring 17, for example, and then you color each link as clockwise or anti-clockwise with respect to each node. So node 10 would say my clockwise, here's my clockwise links, and there are the links that go to node 1 in the previous slide deck. And here are my anti-clockwise links, and they're the ones that go to node 9. And so it was actually link-centric. And we made this change, having thought about this, that it's actually much nicer to have it to be node-centric. So you don't say this is a clockwise link and this is an anti-clockwise link. You say this is a clockwise node, from my point of view, and this is an anti-clockwise node. So that was one big change, and I'll elaborate on that in the next few slides.
Just to be clear, it is that kind of node unless you lose the adjacency.
Yes. Yeah, and I mean, George brings up the point that you have a notion of a neighbor, which is an IGP neighbor. You have a notion of a ring neighbor, which is a node that is next to you in the IGP, but a member of the same same ring. And then you have the notion of a clockwise neighbor and an anti-clockwise neighbor. And in the fullness of time, I've mentioned the notion of an express neighbor or a bypass neighbor. Bypass is confusing because of the use in fast readout, but essentially you could bypass a node and have maybe an optical bypass that connects N10 to N3 or something. We'll get into that detail later, but right now, what's important is what's your clockwise neighbor and what's your anti-clockwise neighbor, assuming your IGP is up. Okay, next. So I'm just showing you a small segment of the ring. Here you see node 0, 1, 2, and 3. And there's a node, so we're focusing on node 1, and you can see that there's two links going from node 1 to node 2. There's a link going from node 1 to node 0, and you have a link from node 1 to node 3. If you color the links as being clockwise and anti-clockwise, and all this is for ring, let's say ring 17, because 17 is a nice prime number. So if you color the links, there's a possibility that you color the link going from 1 to 2 as clockwise, and you color the other link going from 1 to 2 as anti-clockwise, and chaos will ensue. Make Eric very happy, but not the rest of us. So you don't. I'm sorry, I'm up here for an hour, and so I got to do something. So you don't want to have links being colored. You really want to have the nodes being colored. So if you say node 1's clockwise neighbor is node 2, then automatically all the links between node 1 and node 2 will be clockwise, and you won't have this confusion that the links may be pointing in random directions. Or you don't want node 1 to say this link to node 2, the one on the right, is clockwise, and the link to node 3 is also clockwise, because again, that wouldn't make sense.
Question for clarification.
Yeah.
Is the express link also counter? Is it also clockwise, or is it?
So the details of express links haven't been completely worked out. The idea is that you have signaling that's clockwise and anti-clockwise, and the express links are used to essentially do load balancing. So if in this case I have traffic from 0 to 3, I can go 0, 1, 2, 3. I can go 0, 1, 3. And so I might have a load balancing policy at node 1 that says put some traffic on link 1 from node 1 to 2.
Yeah, that's fine. The question I had is,
it's both.
Can you have it go from 0 and then load balance between? So some of the traffic goes 1, 2, and some of the traffic goes 1, 3, 2.
You could.
I think that could get
very tricky. So the best way of optimizing the traffic across the express links is TBD. And this might be a place where a path computation. So path computation on this is relatively simple, because you just, there's a clockwise path and an anti-clockwise path. Where it gets interesting is how to use express links. And so we've had discussions about that, but we're not ready to pronounce on that yet.
Yeah, because all along I've been assuming that they were also counterclockwise or clockwise, and
they're neither, and they're both. So
so that's a very different sort of thing.
Right.
So I'm confused. I'm always confused.
Yeah, I'm also. Me too.
So is the correct way of looking at this that you've imposed your ring structure on your original mesh,
yes,
and the express link is another element of the mesh that's not formally part of the ring, that's just providing a bit of extra capacity between 2 points in the ring?
That's a good way of looking at it. You're saying impose a ring on a mesh. Typically, you dig the trench in the form of a ring, and so it is actually really a ring.
I'm sure. I just. But in topological terms, in terms of general networking, it would have been a mesh if you hadn't made it a ring.
The reason why I mentioned the trench is what happens is, you've dug this trench and you've actually put a node at 0, 1, 2, and 3, and then you realize that there's a lot of traffic going from 1 to 3. You don't want to put 4 transponders, so you want to put 2, so you actually optically bypass it.
Right.
When you do that, you basically you've said what you just said, which is you see a lot of traffic, so I want to create this express path, and now the question is, how do I use it? And
I think you've created a mesh topology and taken all the associated problems.
Well, so that is what is happening, is people create rings and then they create these express links and then they say it's meshy, but it's fundamentally a ring.
And of course it gets to protect. Sorry?
I said not if the express things are not unidirectional in terms of the sense of the ring.
Really not. Yeah.
Because so I'm going from 1 to 3 to 2, and then the link between 3 and 2 breaks. Can 3 send it back over the express link?
Yeah. Yes. So,
but how does one know not to split the load again?
Because it's now using a different label, so that the label is not going to be cross-connected the same way. So you're
using you're using the express link as part of the protection mechanism as well, as opposed to just saying the express link sort of helps make things go faster. But if we fall into a little heap somewhere, we'll just use the ring and the ring protection, and which will be a lot simpler.
Well, so we're starting by just trying to figure out how to do the basic ring and protection.
Yes.
And then we're saying there are these express links, and
Right.
if you can discover that there are express links, then and that itself is non-trivial, because you don't want to create a ring that says 0, 1, 2, 4, 5, 6, and you 0, 1, 3, 4, 5, 6,
Yes.
and you've left out 2, because then you don't know how to get to 2. So you want to create the maximal ring through this, which makes 1 and 2 neighbors and 1 and 3 express neighbors. Having done that, then you say, how can I use express links optimally? And that's where the load balancing comes in. So that's the idea. Now,
Okay.
George brings up a good point, because if you say I'm only going to use express links for optimization, and then if one of these links between, or both of the links between 1 and 2 breaks, how do what do I do with the traffic? It's actually a good question, because you don't want to create a loop. You don't want to come back and load balance over the same thing again. So that is one thing. The second thing is, when that does happen, you might, provided that you haven't created a loop in the process of doing your protection, you might then say, I'm going to now converge to a smaller ring, assuming that, of course, this whole thing that the fiber between 1 and 2 breaks means that not only the links between 1 and 2 break, but also the links between 1 and 3 break, because it's the same fiber and they're just different lambdas. Assuming that that's not the problem, if the links between 1 and 2 break, you might converge to a smaller ring that is 0, 1, 3, 4, 5, 6. So that's another aspect of using express links, is to either node 2 has gone away or the links have gone away. So let me converge to a smaller ring if I still have a viable ring.
I suspect, because we don't normally sort of do multiple sort of concurrent failures in sort of protection systems, you might just as well perhaps consider just falling back to a basic mesh and letting the IGP sort the mess out, because that will always get it right. It may not be optimum, but at least you can continue working until you fix some stuff.
Sure. The problem is that in this kind of situation, you do often have multiple failures, because it's not actually it's 3 links at between 1 and 2 and 1 and 3. These look like 3 links at layer 3, but it might be 1 physical fiber at layer 1. And so when you have a failure, you might actually take the whole thing down. Okay, so yes,
Yeah,
you can
but you
fix
can't
it.
ring wrap a express link. That's
You can fix the problem between 1 and 2 by ring wrapping and going around. You can't fix the problem between 1 and 3 the same way. Or at least if you do, this is I think what George was trying to point out, you have to be careful not to cause a loop in the process.
I think you can.
Yes.
Bryant again. So that's why I was just suggesting that if you really get pushed into the corner, you just let the IGP sort it out normally, because it will sort it out.
It will sort it out slowly, unless you do a lot of fancy computations like the P and Q computations or something, because this is a ring and the IGP will keep saying go the shortest path, which doesn't work.
Or you put a segment routing.
Yeah, exactly.
or something.
But to do that, you have to do those computations that say this is the segment routing path
Yes.
that will avoid the loops, the micro loops, until the IGP converges. So just saying let the IGP sort it out is a little blasé.
Oh, okay.
Okay, so but the fundamental thing here is, I mean, we've sort of dived into the details of how to do protection and how to use express links. The big change was that we're going from clockwise and anti-clockwise links to clockwise and anti-clockwise neighbors, and correspondingly also the express links.
Bidirectional express links.
Yeah. Okay, next slide. So there's a corresponding change to IGP TLVs. There were 2 top-level TLVs. One was a node TLV and one was a link TLV. And the ring link TLV basically identify the clockwise and anti-clockwise links and try to do that with either interface indices or neighbor addresses, interface addresses. And the problem there is if you have unnumbered, you need a pair. So you need to say my address and the remote address, or my interface index and remote interface index. So everything actually just gets a lot simpler if you go from a link orientation to a node orientation. So the next slide shows you what the old node TLV looked like. And basically, I tried to pack a lot of ring information about a lot of rings into a single TLV. I'm an ISIS kind of guy, and I have a very little space, 255 bytes to work in. So I try to be too stingy, but penurious, fancy word for stingy. So that was the old TLV that says essentially I have so many rings that go through this node. And the next slide says what the link TLV looks like, which basically says this is the for this interface, which is identified either by interface index or interface address, here are all the rings that go through it, or here are all the rings that use this interface as a link. And associated with each ring are also a set of flags that say which direction this link is and what OM is going to be used on the link. So all that goes away, and the next slide shows what the new thing looks like, which is essentially one TLV per ring rather than a TLV that contains lots of information. And essentially it says I have a ring ID, I have the flags for that ring, which is really for the auto discovery. And then I could have a bunch of sub TLVs. So only one is defined right now, which is the neighbor sub TLV, which the next slide shows what the neighbor sub TLV looks like, which is essentially the neighbor's loopback address, and then is it a clockwise neighbor, anti-clockwise neighbor, or express, and then the flags, which tell you that plus what OM to use to that neighbor. So the other thing that's good about this is that if I have two links between node, say back to that example, between node 1 and node 2, if I have two links, in the old way I could say over the first link between 1 and 2, use BFD, over the second link use Ethernet EFM. Ethernet in the first mile, last mile, same thing, or CFM. So the three choices are that, but you really don't, I mean, you typically won't have, I'll use BFD on link 1 and EFM on link 2. Per wouldn't use either of those. He'd use, I don't know, pigeons, carrier pigeon? You'd use only BFD, yes. Good man. So again, if you go to a neighbor orientation, if you go to a node orientation, you basically say, this node is my clockwise neighbor, and I'm going to use BFD to that node. And if I have 5 links or 10 links, they're all going to use BFD. It's an oversimplification, but that's what the discovery will do. You can always override the discovery with configuration, but the idea here is not to use too much configuration. Okay, next slide. The other thing is I published a draft. I haven't actually asked for a slot in the IGP document, but there's a draft that give the details of what the TLVs look like in OSPF and ISIS. And the RMR architecture draft will just have a higher level view of what do the TLVs, what information do the TLVs contain, which is on the next slide. Which is essentially, it says you have a top level TLV, which is the type and the length and the values, which is the node flags and a bunch of sub TLVs. And the only sub TLV that's defined is the neighbor type, which has a length and the neighbor loopback address and flags, neighbor flags. Beyond that, the details will be in the IGP draft or drafts. So. Questions? So we'll move on to, I think, RSVP or whatever Nick feels like. I mean, Nick, okay. So yes, pair. Oh, yes. Yes, I should have a mic. Thank you. Scroll. It is aquavit, right? Okay, so this is a draft on how to use RSVP to signal an RMR ring. This is the second version of this draft. We haven't fixed the name, but we will. Okay, next. So I won't go through all these details again, but basically the idea again is not to have any configuration to kick off this. The signaling of RSVP will be kicked off when IGP auto discovery is complete. Two funky things about RSVP. One is this is going to create a multi-point LSP, which typically doesn't happen in RSVP. And the other is it's going to create a loop, which typically is frowned upon, but it's actually, I think, not a bad thing. Since the ring is multi-point,
Can we quote you on that?
You will anyway, right? So yeah, go ahead.
Paris. In Paris.
In Paris, yes. I'll have to find something else to do in Paris. Because it's multi-point, because the LSP is multi-point, the bandwidth can change hop by hop. So node 1 might say, I'm going to inject 5 gig of traffic into this LSP. Node 2, which is ending at node 10, node 2 might say, I'm going to inject another gig. So what node 3 will see is 6 gig, 5 gig coming from node 1 and 1 gig coming from node 2. So the T-spec is going to change hop by hop. Initially, we thought we'll just have a single T-spec that changes hop by hop. But if something goes wrong and if some node says, I want to increase the traffic and that's not possible, you want to kill that attempted increase without killing the entire LSP. So it gets a little more complicated, and I'm expecting Lou to throw something at me, and if he doesn't, then Pawan will. But
so another comment, I believe all the mechanisms you need are already in RSVP if you want to resurrect them, because I don't know if anybody's used it or tested it in quite a long time.
In RSVP TE?
I said
RSVP.
in RS, they're all one protocol.
Well, okay, so I don't have enough history to know that, but we have a proposal here. So if you have comments, please let us know.
So you may run into people who object to redoing it, but that old stuff, as well as I remember, because I haven't looked at it in 20 years.
Well, this is where I'm expecting Pawan is shaking his head,
yeah,
or Lou, who was sitting back there, but he's disappeared, or John sitting back holding up the back wall.
Yeah.
One of them would probably say something, but hopefully say it to the list. So I will tell you how we propose, and you guys can dispose in any direction you want. Okay, next. So hopefully you've already seen this, but there's a new session object that has a new C-type, which is RMR tunnel. Otherwise, it looks very much, well, the fact that it has a ring anchor, which is the starting point of this LSP, and flags, but it has a make before break identifier so that you can change the LSP, and it has a ring ID. The flags basically say, again, like in the LDP case, you're going to create a clockwise and an anti-clockwise LSP, so the flags tell you which direction you're going. Next. So, sorry? There is, yes. Otherwise, yeah, people will throw things at me. There is a V6 version for RSVP, the regular session object, so there will be one for this as well. Yeah. In the LDP case, there was actually the address family. So you could put an address family of V6, and then you'd put 128 bits in there. In this one, we probably have to call out two C types, one for V4, one for V6. Good point. So we're not changing the sender template, the format of the sender template and filter spec objects, but we will allow you to put multiple of them. So this is where George might say that we're reinventing something. But the idea is that on a hop-by-hop basis, you can say, I'm going to put a new sender template in with a new T-spec that says what bandwidth I want. And so as you go down the ring, you'll have to add up all the T-specs and say, the aggregate bandwidth that's going to come to me is all of these bandwidths added up.
Just for your information, the old one had separate messages where the
we consider that, yeah.
Sender IDs are different, but the session is the same all across them all.
Sender IDs. I think we can. So I think we considered having. Well, we considered having multiple path messages. We considered multiple sender templates, and I think that's where we ended up. So, but again, comments to the list will be very welcome. Okay, next. So here's how we're visualizing this to work. You essentially, if you look at the signaling from R0 through R7 and back to R0, that being your ring. At a given node, like in this case in R3, you're going to receive a path message that says, what bandwidth is R0 going to inject into this LSP? What bandwidth is R1 going to inject? What bandwidth is R2 going to inject? And each one is going to have its sender address and LSP ID. And the LSP ID is so it can change things later. And then in there somewhere, it's going to have a T-spec that says what the bandwidth is. And again, correspondingly, the RESB message will have similar things. So that says, I acknowledge that all this bandwidth is going to come in. Next. So this is just a pictorial representation of this. You can see that there's the two counter-rotating rings, two counter-rotating LSPs, which is the green thing. You have R5 essentially inserting the bandwidth that's depicted in blue, and R6 inserting the bandwidth that's depicted in purple. And so they're both going to say in the same path message, I'm going to put my own sender template, and I'm going to say what bandwidth I'm going to use. Next. So if R5 says, I'm going to put in, I forget what the number was, but I'm going to put in some number of gig. R6 says, I'm going to put in some other amount of traffic. And then R5 wants to change how much bandwidth it sends. It's going to introduce a new LSP ID. So it's going to bump the LSP ID and say, here's my new proposed bandwidth. And if everyone's okay with it, the resis will come back and say, yeah, that's fine. If somebody's not okay with it, then they can actually send a path error saying, I can't take that bandwidth. And what's going to happen is that new proposed bandwidth is going to be rejected, and the LSP will continue. Everything will happen, will be fine, but the bandwidth will revert to the old one. So yeah, the details are in the draft. Next. Essentially, you're going to see something like this, and I hope we got this right. You've got R0 saying, I've got a certain bandwidth. I'm going to say that I'm R0, this is my LSP ID, R1, R2, R3, R4. R5 says, I used to want to send some bandwidth, and that's with LSP ID 2. I decided I want to change the bandwidth, so I'm going to send an LSP ID of 3. And that's, so for example, LSP, the corresponding T-spec for LSP ID of 2 with sender address R5 might be 2 gig, and the next one might be 3 gig. And if someone down the line doesn't like that, they can send a path error with sender template 5, sender address R5, LSP ID 3 saying, I can't take it. Next. Yes.
Penelli and Sune. So is it first come, first serve, or what kind of algorithm are you thinking on allocating that bandwidth?
So everyone is going, yeah, it's first come, first serve in the sense that R0 gets the first shot, and then R1 gets a shot. So if R0 says, I want 5 gig, then it gets 5 gig. R1 can then say, I want 1 more gig. And if there isn't 1 more gig, R0 wins and R1 loses. But after that initial round where R1 says, I want 5, R0 says, I want 5, R1 says, I want 1 more gig, let's say that's accepted, and then R1 decides, I want to change that. Or let's say R0 says, I want to change that. The existing reservations are honored. And so R0 said 5, R1 said 1, R2 said 1, and 7 gig is accepted, everyone's happy. Then R0 says, I want 8. And if somebody is not happy, R0's 8 is rejected, but R0's original 5 is still there. So it's first come, first serve, round the ring the first time round, and then, new things are whoever proposes it. If you have a better algorithm, we're happy to accept. Okay. So what's true here is somewhere there's a mechanism that says 0, 0. So if R3 says, I don't want to add any bandwidth to this, what we're insisting is that R3 will add its own sender template, but it'll say 0. And in fact, if R3 said at some point, I want to go to 2 gig, and at a later point says, I actually don't want to send any traffic, it can propose a new sender template with 0, which says, I withdraw my request for 2. And I mean, there's no reason to reject that, but I think it's clearer if everyone inserts a sender template with a bandwidth. If it's 0, it's 0. Yeah. Which is in one of these slides somewhere. Yeah, this is the second bullet here. Yeah. A very important point is in all of this, there's only one label that's going to go around at least between every pair of hops. Even though there are multiple sender templates, there's only one label because that's what you're using for the ring. Next. So one question that we're still struggling with is if a link fails or an adjacency between a pair of nodes goes away, or a node goes away, so we know how to protect this, but as soon as there's that failure, RSVP is going to say, I'm going to tear the LSP down. And in regular FRR, or with FRR with bypass, you send path messages over the bypass to keep that RSVP LSP alive while the head end recomputes. So in this case, we want to know how to keep the LSP alive. I mean, we know how to protect it, but we want to keep the LSP alive. We want to keep the RSVP sessions going until you re-resolve the ring. You might go to a smaller ring or whatever you want to do. And so that's still unsolved problem. We have some suggestions. One is that we're moving to this thing where an RSVP message is not destined to the egress of the LSP, but actually the IP address in the RSVP message is to the next hop. And if you do that, then you just IP route it to the next hop, and you can keep the RSVP sessions alive. But if you have better suggestions, we're happy to do that. The other thing is if the topology of the ring changes, for example, as we were discussing earlier, if a node goes away, but you have an express link that still is up, you can converge to a smaller ring. How little disruption can we do to forwarding in the process? So we know, again, how to protect this, but we want to minimize disruption to forwarding while the ring converges to the smaller ring. Or if a node comes back up, I want to re-add that node into the ring. Again, how to minimize disruptions to the LSP. So, and then the last one is the one that George was bringing up. How best to use express links? Do we only use this for optimization? How do you protect traffic that's going over express links without causing loops? So again, we've had some discussions on that, but we haven't really come to much of any conclusions. We're working on the basic things first, and then we'll come back to this. So I think that's my presentation.
Questions?
Questions? Deborah, you look like you have a question. Okay, so the last one is a different subject. It's fast readout for node production in LDP. And as people have pointed out, there are many ways of doing this. You can do it with segment routing using a label stack that you've computed offline and said, you know, if this link fails, here's how you can get to the next hop. Here, the proposal is to use RSVP for that and to automate much of it. I am an irrelevant person in this draft. The actual authors are Ravi Torvi, Luay, who's here at this IETF, but I haven't seen him at this meeting. Lu Yuan, who I haven't seen at this IETF, and Santosh. Anyway, I'm just presenting. So if you have things to throw at people, just aim them somewhere else.
Do you want to throw something?
What? If you have contributions, though, you can put it in that cup. Okay, next. So this is basically how do I get 100% coverage for LDP LSPs? And we figured out how to do link protection. We also want to do this for node protection. There are no restrictions on topology because we're using a source routed path to get from the node to the next hop. You have to figure out what the next hop is. So you can use many ways of doing that. This one proposes using RSVP. So essentially using existing mechanisms. Next slide. So the idea is here to minimize, so this is just a pragmatic solution. If you have religion, that's fine, that's okay. But if you don't have religion, this is actually a decent solution. Basically, you want to create an LSP from the point of local repair to the next hop, which is the merge point. So you need two things. You need to create a targeted LDP session so you can exchange labels, and you need to create a source routed LSP to that. And here, as I said, we're using RSVP-TE. The other thing that, again, from a pragmatic point of view, we're trying to minimize, how you do this. And so in some implementations, there's a single configuration knob that says, help me, and automatically it'll create a targeted LDP session, and it'll create the RSVP LSP. It'll compute the path, it'll do all the things. One other thing that's important is that this is very similar to how the proposal for creating node protection and link protection for MLDP. So essentially, you're again going to create a targeted LDP session to all the, in this case, you'll have multiple next hops, and then you're going to create RSVP LSPs to those, essentially do ingress replication at the protection point. You could do a multi-point LSP, or point-to-multipoint LSP, but typically you do ingress replication. So we're doing the same thing for unicast LDP as well as multicast LDP. Next. So there's already a fair amount of deployment of using doing link protection with RSVP. So the way many people did it was to create a one-hop LSP over the link that you want to protect, and then create a bypass around that. What we add here is the ability to do node protection, which means you have to go to the next hop, and you need to have a targeted LDP session. So there's a fair amount of deployment of the link protection. The node protection stuff has been worked out. I think it has been implemented, and People have played with it in the lab. I don't think there's any actual deployment of this. Next. So basically, version 4 of this draft has addressed all the comments and questions that have been put to the mailing list. And Stuart is coming up to the mic.
Yeah, it's just that most of the fast reroute works for LDP, etc., really happens over in RTGWG, and I guess there's a potential for some confusion in what happens in two places.
Oh, I don't know. It's been accepted. This draft, as far as I understand, has been accepted as a working document in this working group. So, you know.
Oh, that's bizarre. Sorry?
Oh, sorry. No, it's been no. It's draft Isale. So yeah.
I mean,
do you have a comment?
It's up to the ADs where they want it done, but traditionally, fast reroute for IGP based sort of protocols tends to happen over in the working group.
Chris Bowers, one of the chairs of RTGWG. I mean, we'd be happy to have it over there as well. It might actually get better visibility for the audience that you're going after, which is LDP deployers and not, you know, end-to-end RSVP. And this, in fact, the point is it works for LDP, and you're just sort of surgically including the RSVP for the fast reroute. So it might actually be a good audience to get feedback. Yeah.
Yeah. So I'm just a messenger. I think the higher level, high order bit here is the draft. Comments to the draft have been addressed. The draft has been stable for quite a while. So the authors are requesting that it become a working document. Which working group? Between Chris and you guys. Okay. Yeah. But I agree with you, Stuart, that we should actually socialize it in both places, and then one of them should pick it up and say, yeah, this is the right place to do this work.
The thing that confuses me is that, Stuart again, is that many years ago, where I hardly knew anything about MPLS, I could have sworn I saw something like this sort of described to me. So is this just documenting what's already well known?
It's documenting what's already well known. It's saying, excuse me, to get from the point of failure to the merge point, you need two things: a targeted LDP session, which is
we all knew that. Yeah.
We all knew that, and you need a source error path. And one way of doing that is RSVP. You're just documenting that, and that's basically what these guys are saying.
Okay, I've just kind of thought this was all well known because.
Yeah.
Stuart, did I get you correct? Do you think this is actually documented somewhere else, or is it the gap?
No, it's just. Yeah, but it's not documented in the IETF. But we didn't think it needed to be documented.
Yeah, so I think there's two parts to this. One is which working group, and the other is what kind of document. I mean, assuming that this is interesting work that somebody wants documented, is it a BCP? Is it a standard stack? I don't think it should be, but maybe. Or is it informational? Is it historic? Is it, I don't know what. The authors are going to kill me for that, but that's okay. They're not here. Okay, so that's all I had. Yeah, thanks.
Okay, thank you, Karate. So I think we're done. We are a few minutes early, I think. 20 minutes early. So see you all in Chicago, and go and read up on the draft that people asked for feedback and comment on the list. Thank you.
In March, I guess. Is it cold in March? Or is it still getting warmer again?
Hope for warm, plan for cold.
Okay.
You have Paris the week before.
Is it the week before?
Yeah.
Oh.
So it's
great.
So Paris will be cold and Chicago will be even colder.
Ouch. Chicago will look like,
Yeah.
depending on which way the wind's blowing. The wind's blowing it off the lake.
Yeah. I've been in Chicago in March before, and it was. I thought it would be warm, so I didn't pack enough clothes. I have to go buy a jacket. Yeah.
Okay, nee, das habe ich natürlich nicht gemacht. Ja. Ach so, okay. Na gut, dann